have Vincent Noel, who will tease us about his talk on scientific Python. Give him a hand.
Thank you. Okay, welcome to the teaser talk for the Diving into Scientific Python training session. So in this talk, I'm going to give you an outline of the things I'm going to show tomorrow morning in the training session. The training session is 4 hours long, so here it's going to be a very brief outline of the things that I'm going to show. So first, who is this training session for? Is it for you? The training session is for people who know Python already, but are interested in numeric and scientific applications of Python. And maybe you've heard of things called Numpy, SciPy, Matplotlib, things like that. Maybe you've used them a little bit, but you're not really sure that you know everything or how things are structured in the modules and packages. Or maybe you still feel there's a lot of things you need to learn to use them correctly. So if that's your case, then the talk is for you. Maybe you're interested in using these solutions to solve problems in engineering or number crunching or statistics. So if that's your case, you're good to go. During this training session, I'm going to use a specific distribution of Python to show the examples and to show the environment, the coding environment. This distribution is called Python XY. It's a Python distribution focused on scientific applications. It includes everything that is needed to do science and engineering in Python. So all the packages, all the libraries, everything is inside, everything is in the box. But right now, unfortunately, this distribution is Windows only. So, but if you don't have Python XY, it's fine too, because most of the things I'm going to talk about are cross-platform. And if you have another Python distribution, then you should be good to go too. If you have, for instance, Enfort or Sage or one of these other distributions. So the session is in 3 parts. The first part is during which I show a little bit of context. I show the tools, I show the environment, I show a little bit of story about scientific Python. Then there's a second part during which I introduce the Python scientific stack, which are the tools to use for the coding environment, Spider and IPython. Then I introduce modules such as Numpy for the number crunching and processing, Matplotlib for the plotting and making figures and graphical stuff, and then a little bit of input-output with several different modules. And in the third part, I show a few applications of numerical and scientific Python, a little bit of signal analysis, image analysis, and finally I end with a bit on how to make user interfaces, either using just Matplotlib, which contains a little bit of widgets and stuff like that, or how can you make interactions between PyQt4 and Matplotlib. So during the first part of the session, I describe a little bit of history. I describe how Python got into the scientific game and how it began to be used in science and engineering. Then I describe how Numpy became the kind of de facto standard to make number processing using Python. I describe a bit of how we converged on Matplotlib for doing figures and visual stuff. Then I explain why we need tools like Python XY, which is a Python distribution. So maybe some of you are not familiar with the term of Python distribution. Well, it's a big install file that you download from the internet, a huge file which is hundreds of megabytes. And within this file you have a standalone version of Python, a recent version of Python. And you have packages which are already pre-configured and pre-installed and all the libraries that they depend upon. This is because there's a lot of difficulties in installing recent versions of SciPy, Numpy, Matplotlib, because each of them depends on the other and they require specific names and versions and blah, 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 and specific libraries with the right version number and all that. So the Python distributions solve this problem, and you just have one thing to download and install, and then you're good to go. You have all the tools that you require to do science and engineering in Python. So here on the last line, I show a few of these distributions, and we're going to use the last one. So this is the beginning of the session of the Python scientific stack. It's PSS in short. I'll show you what coding environment we're going to use during the session to show you the examples. I'm going to show you how to use Spider, which is an integrated development environment, which kind of mimics MATLAB. If you know MATLAB, then this should be not very different. Spider includes a lot of useful tools, a file explorer, a code editor with autocomplete, and suggestions for arguments to functions. And if most of the time this is tricky to get right when you code in Python, and Spider works very well with these functions, and even in Numpy, and it's even harder in Numpy because there's a lot of tricky stuff with the import going on. Spider also includes contextual help. When you type the name of a NumPy or a Python function, it will show you the documentation for that function. There's a variable explorer, so you can see what's inside your variables that you're using at the time of your coding. There's continuous code analysis and hints and advices to how you can trim down your code. I'm going to also show you how to use IPython. IPython is a kind of an improved Python console, which gives you more commands that you have in the basic Python interpreter. You can navigate the file system. You have magic commands which let you run Python scripts or look which variables are loaded in the current session. Then I'm going to show you NumPy. What is NumPy? NumPy is a package or a module that provides a new type of variable. It's an n-dimensional typed numeric array. So it's strongly typed. Can be an array will be float or integer, and because of that, they can be manipulated very fast, much faster than the usual Python variables. I will show you how to create, manipulate, and inspect those arrays, how to get the information about the array, how to change the shapes, how to create them based on ranges or stuff like that. I'm going to show you how to access elements in arrays based on Boolean indexing, which is a kind of indexing based on conditions to access elements which are which satisfy a given condition. I'm going to show you masked arrays, which are a way to specify in an array which values are correct and which are invalid, for instance. So you can ignore them when you do your mathematical work. And a bunch of mathematical functions. I'm going to explain a little bit how NumPy functions work with vectorization and broadcasting. I'm going to show you examples that show that these NumPy functions are very efficient for fast number crunching, and I'm going to show you a few speed-ups, a few examples of how it's a lot faster to use NumPy than the standard Python functions. Then I'm going to show you the Matplotlib package or a module, which is a module for plotting, so to create figures, a little bit like MATLAB or R or other plotting tools. Matplotlib is a package which is very easy to learn. The basic functions are very simple, so it's very easy to do easy stuff in Matplotlib. But as soon as you want to do more complex stuff, you still can do it because it's very flexible. Matplotlib can either be used as an object-oriented toolbox or as a MATLAB-like imperative syntax. So you just give him commands and it's immediate on the screen, and you can interact with the figures and resize them, and everything resizes very nicely. So I will show you how to make a few examples. How to do the line plots. The first row are line plots, and how to change the style of lines and symbols and colors, and how to add labels and legends, and how to use LaTeX in the axes or in the text. How to make subplots. How to make pseudo-color images. So it's a way to represent a matrix, a two-dimensional matrix using an image, or contour plots, which maybe you're familiar with. This kind of visualization is how you show depth, geophysical depth, the depth of the ground level. Then I'm going to also show you some more advanced stuff, like how to use datetime objects, how to plot datetime objects, because you can use lists of datetime objects with Matplotlib, and it will understand it, and it will show you, it will display them as dates with the correct format and everything, with various precision. It will either show you years or months, or days or hours, depending on the zoom level that you're using. So it's very powerful and very intuitive. You can use formatters and tickers to select where you want to put the ticks and the information on your axes. It's very flexible. I'm going to also show you how to use masked array from Numpy. So Matplotlib understands this masked array, so it knows that it shouldn't plot the invalid values, so it ignores them. To end the Python scientific stack part of the training session, I will show you a bit of input-output using various modules, how to read tabulated data from ASCII files, which are kind of like CSV, but NumPy understands this kind of files, but it also understands the kind of ASCII files that are very current in science application, with headers and documentation inside the file, and it can load those without without a lot of work. I will show you that with SciPy.io you can read and write MATLAB files, the mat files, which are kind of proprietary to MATLAB, but with SciPy you can read them. How to read Excel files using Excel read and Excel write. And also, very briefly, how to read netcdf files using the netcdf4 package. Maybe HDF if there's interest in that. I will show you a bit of some examples on some scripts that read the data file and produce this kind of figures out of them. So how do you get from the data file, either in ASCII or in mat format or in netcdf, to these figures in very brief, very short scripts, like 10, 15 lines, and how to save them in PDF or TIFF or PNG or whatever. And during the application part, first I will show you how to do, I will give you a few examples on how to do signal analysis using SciPy, so signal smoothing using Fourier transforms, and how to plot it just like that. A little bit about image analysis, how to process images using a bunch of various filters, Gaussian filters, but also others. How to do object classification and morphological operations on image, binary erosion or closing, binary opening, this kind of stuff, and also automatic object classification. So with these tools, you can identify individual objects in an image and separate them, give them numbers. And for the last part of the training session, I will give you a few examples on how to do user interaction. First, using Matplotlib widgets. So these are like extremely simple widgets that you can use to create user interactions. You can create buttons and sliders, and the user can click on them and it reacts automatically, and it's very easy. It's also a bit on the ugly side, but it's very simple to put together. And finally, I will give you a short example on how to create a Qt4 interface to display to the user, but still use Matplotlib to show the results to the user. And that's it. Thank you. So do you have any questions, or you wonder some things are going to be discussed tomorrow or not?
I'm passing you this.
I just wonder, do you have somewhere on the internet a sample code so that Linux users can try if we have all the right tools for the workshop tomorrow?
Yeah. The plan is to upload all the data files. I will use as sample the presentation itself and all the code samples to create the figures and everything. Right now I can't really upload anything because the Wi-Fi doesn't work in Florence anywhere. I can try, but I haven't found an internet connection anywhere right. Okay. Hope not.
I would like to ask just what is the kind of licensing that is used for this kind of stuff? Can I build a closed source application based on the tools that are Numpy, Matplotlib, and something like that?
Develop a closed source application based on that? Frankly, I have no idea. I know that all this stuff is kind of open.
Yes.
And you're free to use it and develop your own tools and all that, but I don't know if you can take it and make a closed...
I mean, make it a part of a closed, front end to show something, but for something that is not open source.
I'm not sure. It's not. Okay. I don't think it's GNU licensing, but
okay,
maybe it's the same
I
as
will
the
check
Python
on
license.
the internet.
Sorry?
I will check on the internet and the tools, but.
Hi, two questions. First, there is a 64-bit version of Numpy, SciPy, all the libs.
Well, the versions that you download from the internet, like the standalone versions, are source code. So if you have Python as 64-bit, it should work as 64-bit. But you need to have all your libraries already compiled in 64-bit.
The problem is, for instance, Numpy I need to compile it by myself. I didn't find a 64-bit version so easy. It's not easy to find. Also for SciPy.
I think in the NFOT Python distribution, everything is 64-bit.
Are you sure? Yeah. Okay.
Okay.
And second question is about something like a PyOpenCL, some way to do massive calculation using graphic cards. There is something inside the toolchain that you...
I don't know if it's yet included in these toolboxes, but there's a lot of work on that right now. I think there's something called PyCuda, which does GPU-based acceleration, and I think there was a talk about it sometime.
But PyCuda is also all for NVIDIA cards.
Oh, sorry?
You cannot use PyCuda if you have a ATI graphic card. Just asking something in general like OpenCL, I don't know.
I'm not aware of any of these solutions.
Thank you.
So there is just space for one more question. Okay.
Sorry? In all these toolboxes, they require a pretty version of Python, but not Python 3. So it's going to be like Python 2.4 to 2.7.
Oh, can I ask you another question?
Yeah.
I just saw lately that they finally port these two libraries, so CPy and Numpy, to the Python 3. So did you try to use it with Python 3, and what's your opinion on that? Never.
I use these for my work, so right now I don't have the courage to try and use things that might break.
Okay, thanks.
Okay. So your training will be tomorrow. What time?
Tomorrow at 9.
Okay. So let's thank Vincent, and if you're interested, his training will be tomorrow at 9 o'clock.